I'm working on expanding this phone line simulator project where up until now I have dedicated node-to-node connections between two phones, but I'd like to get more nodes integrated so one can call one or another, or even all of them can be on a multi-node simultaneous connection together. Or if I have a whole bunch of these nodes, I can have simultaneous connections, like this phone can talk to this phone while this phone is talking to yet a different phone. And although this uses ESP32 plugged in on these sockets, the actual phone audio connection is still a landline with a phone jack on each board. So there's a phone cable that plugs in board to board directly, and then the other jack on each board has a telephone plugged in. So when one phone dials a number, it will wirelessly communicate with the other board to find out if the board is available to take a call. And if so, then it closes relay contacts and makes a physical landline connection between the boards. So to allow multiple nodes to interact as needed between each other, I made this subscriber line audio matrix board with today's sponsor, PCBWay. So this also has an ESP32, again, to wirelessly coordinate with different nodes. But again, we have a bunch of phone jacks. I have 8 down here and 3 up here. So the goal is I will still have a landline going between each board and one of the available slots on this matrix. So a bunch of boards will be wired in here for the analog audio connection. When a phone dials from here to here, instead of directly wirelessly communicating to coordinate the call, the system is not ready functionally yet with software, but now each node will talk to the ESP on this matrix. So this board would tell this board wirelessly, I'd like to call the number associated with this board. Then this module will ask this one, are you available for a call? And if so, now with each one having a landline connection up to the matrix, this ESP will route the call from one node to another. So for example, I can have a line plugged in here that gets connected to another line over here. Or then you hang up the call and you connect to one over here. Or you want a three-way call, you have this one and this one over here all joined, while you have another separate phone call going on elsewhere. So basically what this project here has is an 8x8 analog matrix with an MT8808 IC. And there's a few other support components on here. So we'll look at the schematic, but as an overview of everything here, when the ESP wants to route a call from one line to another, what it's doing is telling this matrix to connect this line with this line through its internal analog switches. There's also a DTMF decoder circuit here because possible future expansion could be that if we want to do some configurations, we could have a board sending out DTMF touch tones, and then the ESP module can detect the tones and follow instructions or change configurations. And these 3 extra phone jacks up here, I'm considering to be trunk line expansions. So here we have 8 slots, but if I wanted more, I could send calls out on this trunk line to go to another board like this and continue routing calls on another 8 channels or something like that. And we see these lights here. I just have a demo sketch for now. Since the whole thing is not functional, I'm just going to use sine waves later. The lights have different colors to indicate which channels are currently on the same path. So right here we have red and then red. So if I plug something into this phone jack and this one, the matrix currently has an analog path between those two. So I could send telephone audio here and complete a call. Likewise, there's green and green. So if I plugged in one of these phone interfaces here and here, those would be also connected as a separate call. And over here, I'm just testing with switching on these blue lights. So this one is always on, and then we're momentarily switching that call between 3 other nodes. So I can put a sine wave in here and look on the scope and see if it's coming to all these channels at the time expected when the light is on. So if I'm scope probing this channel here, I'll see the sine wave show up when this light is on, and then it will disappear until this light comes on again, showing the call is being routed and analog audio is passing through. So now we can look closer at the schematic for an idea of the circuitry, and I'll look at the schematic more as a block diagram. So here's the DTMF decoder. It's a standard circuit we've used before. So it has the digital data representing touch tones being pressed going to the ESP32, but I'm not using this right now. It's just in this analog matrix where I can connect signals down onto this line here and send audio into the DTMF decoder when I want to detect touch tones. So we don't really need to do much with this right now. Then I have a negative voltage rail generator. I'm powering the board at +5, so this generates -5. Then on the analog matrix, I have plus and -5, so I can have audio signals passing through. Since the ESP is running at 3.3 GPIO, I need to talk to the analog matrix at 5 volts, so I'm using FET level shifters to go from 3.3 to 5, and I'm controlling the 8808 matrix with a PCF8574 GPIO expander. So that's I2C with the level shifter and another dedicated control line with a level shifter. So basically, all we need to really focus on for the principles here is this analog matrix. So when we do want to route analog signals through, the ESP tells the GPIO expander over I2C what control pins to set to make new analog connections. So here we have 8X and 8Y paths, which I've sketched in loosely as vertical and horizontal lines representing a grid of nodes inside here. So what this chip does is allow you to close the connection, making a circuit path between a certain X and a certain Y line. So I've drawn in on X0, we connected the node at X0 and Y0. We also connected the node at X6 and Y0. So what we're doing is creating a path from a signal on X0, getting down to Y0, and then it's on this horizontal line. Then we close another switch here, making contact with this vertical X6 line. So we have a circuit path going from X0 to X6. And that would represent phone jack connections on that circuit board. So a phone cable plugged in here has analog audio able to pass through and come out to the other one here. Of course, it's a two-way audio path. So that's how we make a telephone audio connection after a call is placed. So if I wanted to listen for DTMF touch tones from a phone plugged into this line here on X0, I would tell the chip to also make a connection at Y7. So then X0 comes to Y7, and that's connected to the DTMF decoder, and now the ESP can listen for touch tones. So in previous projects, I've used a similar product, the MT8816 instead of 8808, which is an 8x16 matrix. So I talked more about how all this works, and none of this is really brand new stuff. So I just wanted to do a high-level discussion. And then we just have all of those phone jacks and those LEDs associated with each phone jack. So we just have back-to-back Zener diodes across the audio path on the phone line to clip it if it gets too loud. And the signals are all going to those matrix channels. The LEDs are SK6812 RGB. So from the ESP32, we just have the data line going to the first LED as usual, and then it cascades from LED to LED, and we can turn on or off certain LEDs and change the color to represent activity of different sorts on each phone jack. Now we can put this on a scope and see what happens when we're switching channels as a demo for now, until the board is actually ready for the telephone functionality. Here's a test setup to try out the board. And I can't fit everything on screen, so I'll just explain the overall part and then zoom in toward the scope. I have two phone cables to go between various phone jacks. One of these is being fed with a sine wave from a signal generator through a phone jack on the breadboard. So the cable comes around to this bundle and plugs into this first jack. Then the second cable here comes over to another breadboard jack, and that just goes to a scope probe so we can see what's happening. And what I'm going to do is just take these cables out and move them between different jacks to see the behavior with the software I put in here. The bottom trace on the scope is the sine wave coming out of the generator, so that's what's going into the first jack on this board. The top trace is the other cable signal, so it's switching between a copy of the input sine wave and what looks like a little ripple. That's actually 60 Hz noise, so it's really just no signal or the input signal being channeled. So here's what's going on in the board. I've got software in the ESP to control the MT8808 matrix to route audio between various channels here. So the LEDs light up to show in different colors any channels that are in common. So over here I have 2 red ones and then 2 green ones. So that means if I plug a phone cable into both red ones, it's always passing audio right through. And the same with the 2 green ones, it's always passing audio right through. Over on these other 4 channels, the leftmost one is always on because that's the input sine wave. Then, one by one, we're turning on and off 3 more channels. So whichever one is lit at a time, this channel 1 is being connected to channel 2, 3, or 4. So when we are on channel 1, that's when we see the sine wave showing up on the top trace because it's going to this cable. And then it's off while the signal is routed to other channels. So if I just plug this output signal into the next one, now whenever that second light comes on, we see the top trace passing the signal. If I go to the final one, now when that final blue light is on, the top trace shows the signal is getting through the cable. Now, if I plug the cables into 2 red colored jacks, we now have the input sine wave on one of the red channels and the output on another red channel. So we just see the input signal being continuously routed to this output cable. If I plug one into red and one into green, all we're seeing is 60 Hz noise, which I can impact by touching things. And when I take both cables and put them to 2 green channels, again, we're just passing the input signal consistently to the output. And this channel switching over here isn't having any impact because nothing's plugged in. So that's how I was able to demo that I can use this matrix chip to switch audio between all of the signal paths. And later, when I get telephone line simulators connected up here, I can coordinate multiple telephones, modems, or whatever. Now that I have the board up and running, it's just a matter of working on software, even though for me that will probably take another long while. But at least I have something to work on here and there between other projects.